Hi, I'm Ms. Boom. Today we're going to look at recognizing relationships. Here we have a graph with y and x, and we have seen in previous years that we can look at y and describe things like distance from home, and we can look at x and use it to describe things like time. When we do distance, we can use meters or kilometers. When we do time, we can use seconds, minutes, or hours. We can also look at water height in centimeters and meters, and we can sketch it against time to see how the height of water in certain containers changes. Let's do an example where distance from home is this line over here. Now there's a 6 there, it's a bit tiny, you might not see it. So the line is at 6 and it's continuous, as in like it doesn't change. So we can see that even though after 1 hour, 2 hours, 3 hours, the position from home is still 6. That means you haven't moved. You've been staying still at 6 k's away from home. What if you have a line that looks like this? So here at 0 times 0 at the start, you are 0 kilometers from home, so you're at home. But as time moves on, you're moving further and further away from home. At 2, you're 2 k's away. At 4, you're 4 kilometers away. At 10 hours, you're 10 kilometers away. So you're going away further and further from home. But if we sketch another line here, this blue one here, we can see that one of these is you moving faster. Which one would that be? Well, we can see that after, let's say, 2 kilometers, the pink line is at, after 2 hours, the pink line is at 2 kilometers, but the blue line is at 6 kilometers. So we can see that the blue line has moved more distance, or in other words, the blue line is faster. And we can use the pen trick, see, the more vertical, so the steeper it is, the faster it is. Conversely, the shallower, it should be slower. So let's check. After 5 kilometers, the pink line has moved about after 5 hours, the pink line has moved 5 kilometers, but the purple line has only moved around just under 3 kilometers. So the purple line is moving a lot slower. These 3 lines are all moving away from home at different speed, fastest to slowest, or steep gradient, shallow gradient. Please remember, anything vertical is steep, fast. Anything shallow or horizontal is slower. What about if we had the line going that way? So here at time 0, we start at 9 kilometers away from home, and at time 9 hours, we're 0 away from home. So we start away from home and we're coming towards home, which means in this graph, we're describing somebody going away who started away from home, coming towards home. And here we have a blue line again. This is, even though it's negative, so this is negative, this is this is closer to vertical, so this is faster. And you can check, this person gets home in half the time. And like before, we can have a shallower or a slower graph if it's not as steep. So remember, the more vertical your line is, whether it's pointing down or pointing up, the faster or steeper you are. The more horizontal, whether you're pointing up or pointing down, the shallower or slower you are. Now, the gradient here in these 3 graphs is negative. What about when we talk about water height? Well, we can have, again, the same graph to describe how much water in a container, and we can see that the blue container has been empty in less time. So again, steeper it is, the faster it moves. Here we have a graph, distance away from home again. So in this instance, we are going fast because it's steep, away from home. We stop for a while, same distance, and we go slow back home. So the gradient here is how fast it is, distance over time. Here we have 2 containers. If the water was dripping in them at the same rate, which container would fill up faster? Or if you put these 2 containers on a tap, which height will move up faster? We know that when we fill up a water bottle, when we get to the little nozzle at the top where it is narrow, it moves really fast. So we know this is the faster line or the blue line over there. Whereas this one is represented by the pink line, slower. What about a shape that looks like this, if you're filling this up? Well, we know that when it's wide, it is moving slow. When it's narrow, it's moving fast. So slow, then fast, or shallow, then steep. So our graph will look like this. See, shallow, and if I follow the graph, it becomes steeper and steeper. What about these two? Which container represents filling up which line? Or which line represent the containers? So we can see that in the pink line, we're going from really fast to really slow, really quickly. Whereas the blue line is fairly fast and then kind of slowing down gently. So we know that the pink line belongs to the cocktail or that glass there, and the blue line belongs to the milk. Here we have a bathtub. Let's say the height of the water of the bathtub. Would you be able to come up with a story of what's happening here? Perhaps here the water is slowly filling in and then really fast. So maybe you just turn on the tap at max and it fills up, and you turn off the tap. Maybe you jump in the bathtub so the water went up, and you stay in there so the water doesn't change. And then you get out of the bathtub. See, the difference in getting in and get out is the same. It's probably you getting out of the bathtub, and then you can stop for a bit, and then something's going, the water's going out. So maybe you take the plug out. So fast and slow. Take notice of how steep something is or how shallow something is. You might want to fill up your notes with the keywords in here. Here we have another one. Here we can see that I'm running pretty fast, taking a break, running pretty fast, taking a break, running back home really fast. Remember, we're going away from home towards home. Remember, this is 0, y equals 0. So this is when we're home. This is y equals a bigger number, so away from home. And we can see that even though this is fast, the next blue line, it is more steep, so faster. And then we have a pause, the purple line, and then this is really shallow, so we're going slow. Here's another graph. Let's see if you can fill up your notes with a story to describe what happens to this bathtub with the water level increasing and decreasing. And I've got another 3 graphs if you want to practice some more with a friend, if you're watching this with someone else. To summarize, the y equals fx function or line, if the graph shows that y is increasing as x is increasing, then the rate of change of y, or the gradient, with respect to x is positive. So these are positive. So as x increases, y increases. Positive. If the graph shows that y is decreasing, so the y value is getting less as x is increasing, then the rate of change of y with respect to x is negative. We're going to substitute rate of change with ROC for a shortcut. So whenever you see ROC, think rate of change or gradient. Example 1. For the graph shown below, where x is an element between -5 and 2, use the interval notation to describe the set of values for x for which the graph or the rate of change of y with respect to x is positive, so when the gradient is positive. And then we're going to look at when the rate of change with respect to x is negative, so when the gradient is positive, when the gradient is negative. So between -5 and 2, -5 and 2. So this is the graph. When is it positive? So it's positive when it's pointing up. So we can see that's positive between this turning point. So here -3 to 0. Remember though that we do not know the gradient. It is not positive at -3 or 0 because the gradient there is 0. It's flat. So it's -3 to 0 with curved brackets because it's not including -3 and 0. At those points it is 0. What about when it's negative? Well, it's negative between in this section here and that section there. And just like we couldn't include the -3 because the gradient is 0. We can't include the endpoints even though it's inclusive because we don't know what the gradient is there. We cannot find out the gradient of a dot. We can only find a gradient of a chunk of line because the gradient is how quickly something changes, how quickly y changes with respect to x. And if there's only one y, then there's no change. So anyway, when is it negative? We can see that's between -5 and 3, but not inclusive of the two values. Union 0 and 2, again not including the two values. Not including 3 and 0 because the gradient is 0 there, and not including -5 and 2 because we have no gradients at the endpoints. That's it for me today. I'll see you next time. Thanks for watching. Bye!